Hello students, now class 12th. Today I will tell you about the PN junction diode. Junction diode. Now sometimes it is called PN diode or sometimes PN junction, and you can know that there are the word junction. Junction means when you have heard the name of railway junction. So we have taken this word from that one there where the trains coming from different directions meet at a single station. Then this is called the junction. So here also we are having the two crystals P and N, and they are joined together. So they have a junction between them. So this is called the PN junction. When P and N type semiconductors are joined in such a way that the crystal structure remain continuous at the junction when P and N type semiconductors are joined in such a way that the crystal structure remains continuous at the junction. It is called this device is called PN junction. So this is like this. This is not junction. This is P part, this is N part. In P we are having the holes, and we know that there are certain impurities, so they gain the electron from the adjacent atom, and that they become the negatively charged. So impurity atoms become negative charged particle. This is here are some electrons. These are the electrons. Here in the N type semiconductor, they donate the electrons, so the impurity atoms are positively charged, and electron is given by them, so they are the donor type of impurities. So we have this is the electron, this is, and this makes the depletion region. This is x1, this is x2. So this is called so much depletion layer. Here I have shown you this, the electrons. This is electron. This I have shown you the hole. This is the hole. So now in P part or the P crystal, there are the holes in comparison to the electrons, and in N part there are majority of electrons in comparison to the holes. So when they are made in such a way, then at the junction there is the flow of electron and hole through the junction. The P crystal. The P semiconductor and N semiconductor have majority charge carriers the holes and electrons respectively. The holes from P semiconductor diffuse towards N semiconductor. And electrons from N semiconductor diffuse towards P semiconductor. Across the junction. What happens? The holes from P goes to N and electron from N goes to P. They diffuse into each other, and thus at the junction, so this junction is just between them. some electron and holes combine with each other forming electron hole pair, which is neutral, and such pairs get collected near junction. The diffusion of holes and electrons continues till an equilibrium is attained. The negative ions in P part and positive ions in N part are accumulated near the junction and forms a layer having no free charge. It is called depletion layer. Depletion layer. X1, X2. There is electric potential across the junction called across the junction, and it makes a potential barrier. Potential barrier X1, X2. The potential difference across junction varies from 0.3 volt to 0.7 volt. The thickness of depletion layer is about 1 micrometer, approximately so much. And then you can have that, if suppose we take this is now your X, and here we have the potential V on this side, then this is now X1 and this is X2. So the potential difference across this X1 X2, this is from 0.3 volt to 0.7 volt. So it varies like this. The potential difference in depletion layer give rise an intrinsic and internal electric field. Internal electric field denoted by EI. EI. Now this electric field stops the diffusion of electron and hole. Let's suppose electric field EI is equal to V upon X. So X is what? This V is equal to 0.7 volt and X equal to, suppose this 1 micrometer. So this is 10 to the power minus 6 meter. So you can have that this EI is equal to 0.7 upon 10 raised to the power minus 6. So this will give you this EI equal to 7 into 10 raised to the power 5 volt per meter. This is a very strong electric field. It is very strong electric field. Which stops of the diffusion of holes and electrodes. And the thickness of this depletion layer, the thickness of depletion layer depends upon following factors. Number one, nature of crystal. Nature of crystal means that whether this is the end, your germanium or silicon like this. Number two, temperature. And number three, amount of impurities. These factors affect the thickness of the depletion layer. And since at the junction we are having the one part to be negative and second part to be positive, in depletion layer, region in P semiconductor is negative, and that in N semiconductor positive. So it is just like cathode and anode of a cell. Because of it, the name is given the diode. So if we have, then this is now your di plus ode. Di means 2, ode means electrode. Electrodes. Since just I show you that in the depletion layer the part towards the N, this is now negative one, where the negative ions are present, and part on the P crystal, the part is there is the positive ions. So negative and positive ion form a layer, that is called the depletion layer, and this negative ion behave like the negative this cathode, and the positive ion behave like the anode. So we give the name diode. Di means two, ode means electrode. This is just like having the two electrodes. So depletion layer is just like the diode. So this gives that in the depletion layer there is no free electron, and the resistance of depletion layer is very high, because free charge carriers are not available. So the resistance of the depletion layer is very high, or it is approximately to we can say that just behave just like the insulator. So this is what the formation of PN junction diode, and why it is given the name diode, why it is called the junction, that I have told you. So also the thickness of depletion layer depends upon what factors that I have told you here. So you all read this, watch this video and study. It is very important from the point of view of your exams and also the competitive exams. So you all like, share and subscribe this video. Thank you.